A well-known issue when designing video games is the balancing of difficulty, along with keeping the player within the flow zone. As different players have different flow zones, one static solution is simply not efficient enough to ensure quality game experiences. The flow zone is defined as a place where game difficulty matches the skill level of the player, thereby ensuring a challenging and engaging game experience. However, one flow zone is usually not enough to define all players, leading some to become anxious as difficulty rises too fast compared to their skill level, and leave some bored as the difficulty does not rise according to their skills. One solution to this issue is known as dynamic difficulty adjustment, which is when the game dynamically adjusts the difficulty to the player's performance in an attempt to keep them within the flow zone. This approach has been seen in games like Resident Evil 4 and Max Payne in the original DDA form, but the scope of this project is to create a video game with an attached reinforcement learning AI to control the difficulty aspects of the game and then proceed to compare it to the traditional DDA approach for the same game. The game was implemented using iterative design, doing multiple cycles of the same implementation, and the result was a game to train typing skills for the player. The player is supposed to avoid bumps by typing the words above each lane to move the boat. The general findings of this project included a small but significant difference in the average game time for either version. Observations and statements made by participants at the testing site confirmed that the reinforcement learning AI was very efficient when adapting difficulty, and that the regular DDA version was efficient but not as efficient. However, one concern emerges from the testing session. Reinforcement learning was efficient in this case, but it is plausible that reinforcement learning DDA is not applicable to a wide range of game types, making it a somewhat limited option.